Okay, I think I'm visible now. So, in this session, I'm going to discuss about the research design formulation, that is fourth unit of block 2 of MMPM-6. Okay, so unit 4, research design and formulation. So, research design is a detailed blueprint for the research study that will be conducted and provides a general outline of the procedures that will be used. Okay, I mean that is a general. Okay, now I think it is a kind of blueprint or the general outline of the procedure that will be used in the research process. So it is a kind of framework for the research study and a map that directs data collection and analysis. And it provides at least the following information to be effective. It means if research design is effective, it means it should provide the following information. The first it is the statement of the objectives. Okay. Okay, the following three kinds of information is provided by the research design. The first it is a statement of the objectives of the study or the research output. That is, first it is the statement of objectives. Second it is the data inputs required. So what different kinds of data inputs are required, so that also. And then after, third it is given analytical methods to be applied to process and analyze the data. Significance of research design, that is first given here. So first significance here given. The first, it specifies what must be done and how it must be done in order to accomplish the research objectives. Then second one, it anticipates expected outcome and analytical inputs required. Third, provide direction to the computation and interpretation process. Causality, the basis of classification of various types of research design, means various types of research designs are classified based on causality. Here given the following three requirements are satisfied before drawing conclusions about causation. First, concomitant variation, the degree to which a cause X and an effect Y occur simultaneously or vary. Second, given the causal factor must take place either before or at the same time as the effect factor. All other possible factors influencing the outcome are either absent or kept constant. When outcome is completely determined by one causal factor, the causal factor is the deterministic cause of the outcome. Three possible ways to control the influence of extraneous variable. The first way here given, the exert physical control over the extraneous variable. Second, given, randomize the assignment of treatments to test units. Third, it is given use of experimental design. So these are three ways to control the influence of extraneous variables. And types of research designed here next given. So for following four types given. First, exploratory design. Second, descriptive design. Third, quasi-experimental designs. Fourth, experimental designs. So now let's discuss these all one by one. So the first, exploratory design, research design. So when the researcher wants some early insights into a problem to get a better idea about the scope and context of the problem, then exploratory research design is used. It helps to understand research problems more clearly. Primary objective of exploratory research designs are as follows. So first, define a research problem. Second, identify various courses of action. Third, create proposition and hypothesis. Fourth, identify primary variables. Fifth, developing approach. Six, suggesting priorities for future research. Methods for exploratory research design. So what different methods are there for exploratory research design? The first, it is expert interview. Second, pilot surveys. Third, case studies. Fourth, analysis of secondary data. So these are four methods for exploratory research design. So expert interviews, it involves marketing problems can be solved by speaking with people who have expertise and ideas about the research topics. Second, you have survey of existing literature. Means published literature presents a very economical source of a study for the purpose. Descriptive research design given used in preliminary research study or preliminary studies to make it easier to describe population parameters and draw conclusions about how two or more variables interact with one another. To establish. So descriptive research design is also used to establish the relationship between elements to which while describing the event being studied. Mandates. So mandates of descriptive research design is who, what, when, where, why, and the way of research to be conducted. So who is the consumer of a particular brand? What is the information to be captured from the respondent? At what time should the information be captured from the respondents? Where the location at which the information has to be captured from the respondents? Why? So why the specific information is to be captured, and ways, means the protocols to be used for collecting the information. So cross-sectional design here given, take a one-time survey of the situation or phenomena that interests the design maker, may uncover relationship that can be tested conclusively using experimental designs. Longitudinal design here. In this specific sample is drawn from the population, and the questionnaire is administered to this sample at two or more points in time. Samples remain in different phases of the data collection. Focus group, gathering a group of people to engage in an extensive free-flowing discussions about their experiences or viewpoints. A standard procedure, record the conversations that on tape and later analyze them. Then next, the discussion is led and guided by a moderator. So the goal is exploratory and the success depends on a well-trained moderator. So next we have the factors influencing experiments validity. So two factors are given here. First, internal validity. So factor internal validity, no other plausible cause of the observed results should exist except those tested. So what given here, no other plausible cause, means other than the cause which is causing should not be present. So that given, no other plausible cause of the observed result should exist except those tested. So this leads to internal validity, and external validity relates to the question of generalization of the results obtained from the experiments. If the results obtained from the experiments can be generalized, it means it is externally valid. That's here. Then the next thing, extraneous elements that can affect an experiment's validity, that is the history, means the occurrence of a specific non-recurring events that are external to the experiment but occur at the same time as the experiment. Maturation of the people involved in the design testing. Respondents may know that their behavior is being observed or the results are being measured. So that's about the testing. So these are extraneous elements. Testing, respondents may know that their behavior is being observed or the results are being measured. And next we have fourth one, instrumentation, refers to the effect caused by changes in the measuring instrument or process during the experiment. And fifth we have the selection bias. So these are five extraneous elements that can affect an experiment's validity. Quasi-experimental design. In this, the researcher has control over the data collection procedures but lack control over the scheduling of the treatments, and also lacks the ability to randomize test units exposure to treatments. Weakness here given that it is internal validity is questionable. The internal validity is questionable and lack the control attribute of truly experimental design. So why the internal validity is questionable? Because uh, with the treatment there are some other factors. Other factors are also, or other causes are also present when we give the treatment. So we cannot say exactly which factor caused the effect. So that's why here the internal validity it is questionable. Types given here: after only, without control group; before, after, without control group; the static group comparison; and longitudinal design. So these all we are going to discuss. So these are different types of quasi-experimental designs. The first quasi-experimental design is given after only, without a control group. It means one short case study. A single group of test units are first exposed to treatment, and then measurements are taken on the dependent variable afterwards, in case of after only, without control group. So limitation given that the result may be due to various uncontrolled factors. Second, we have before, after, without control group. One group, pre-test, post-test design, provides a measurement of what existed prior to the test group being subjected to the treatment. So that symbolically here given O1 x O2. So where O2 is the dependent variable afterward, and x is the treatment, and O1 that is the test group before treatment. Static group comparison design. So use two groups of subjects, just like group 1 is exposed to the treatment, whereas group 2 is not, or you can say has not been exposed to it. Group 1, that is experimental group, here given, is provided with the treatment, and then we observe that what happened due to treatment to experimental group. And group 2, that is the control group, baseline marketing program. It means in case of second group, that is the control group, we do not provide external treatment. So that's what we did here. We took two groups, means experimental group and the control group, and we provided treatment on the experimental group and then observed its effect. And on second, the control group, we did not provide any kind of treatment and then observed. So here we compare the two groups after treatment. So in first case it was treated with some cause, and the second one, in the second case, we did not provide any kind of treatment, and we compared those two. Longitudinal design, that is also known as the time series design. We take periodic measurements for some test units. The treatment is introduced and the measurements on the test units are again taken at various points in time. So that's here what given here, periodic measurements for some test unit and sub test unit. Now you can observe here on the right hand side. So A, B, C, D, E, F, these all are test units. Okay, treatment is introduced on these all test units, and measurements on the test units are again taken at various points in time. And then we observe that how the test units had changed due to treatments. Because of multiple measurements, the effect of maturation, testing, and instrumentation can be ruled out. So these all things just like effect of maturation, testing, or instrumentation can be ruled out, and we can conclude that whatever there is a change or the effect in the test unit, that is due to the treatment which has been provided. So weakness not possible to control history. So that's why it may be possible that a particular event generally occur at one particular moment of time. So that's why history we cannot control. Now next we have the experimental design. So experimental design provides a stronger and more reliable basis for the existence of causal relationships between variables. Eliminates means experimental design eliminates all extraneous variables from the experimental and control groups through the use of a random selection procedure. Advantage is that can be used means it can use inferential statistics. Means in case of experimental design we can use inferential statistics techniques just like ANOVA and something like that. And types of experimental design here. First, after only with one control group, before after one control group, the Solomon 4 group design, completely randomized design, and randomized block design, and Latin square design. These are different types of experimental designs. So the first experimental design here given after only with one control, after only. So control group is set up by randomization procedure, requires only one treatment and a post-test measurement of both the experimental and the control group. So that's here. Symbolically we can represent this as we can observe on the screen that the experimental group has been provided the treatment, and then after observation has been taken. But in case of control group there is no treatment and simply the observation has been taken at the same time when the observation it was taken for the experimental group. No pre-test measurements are taken in any of the two groups. Okay, means no pre-test measurements are taken in any of the two groups. Means only taken means measurements are taken after the treatment on the experimental group. So widely used in marketing. So before after with one control group. So what we do here in this case, experimental groups and control group, for both groups we take measurements before providing the treatment, and after providing the treatment we take another observation and then conclude that whether the effect is due to that treatment or not. Extraneous variables operate equally in the experimental control groups. So we can say that the only difference between the two groups is due to experimental groups treatment. But what is the problem here in this case? The problem is sensitivity test effect. Okay, so here given problem, sensitizing test effect. The individuals in the experimental group get affected because of the pre-test measurement and may become cautious and behave differently after being exposed to treatment. So that is a problem with pre-test before after with one control group. Third, it is the Solomon 4 group design. So what happens in this Solomon 4 group design? So combination. So yes, here a combination of the before and after with one control group, and after only with one control group design. So here what we do, we use 4 groups. Okay, in case of Solomon 4 group design, here first is the experimental group. So in first case experimental group we take the observation, then we provide the treatment, and then we observe again. And in case control group, without any treatment we take the observation. So that's here. In case of control groups, O3 is the observation before any kind of treatment, and O4 is again the observation without any treatment. Okay, And then next, here you can observe in the third line, experimental group, no treatment is provided, and again in case of a control group, no treatment has been provided. So that's why here the respondent get confused or not able to understand that exactly there is some kind of experiment is going on or not. So it eliminates the sensitizing testing effect. So the fourth one, we have a completely randomized design. Test units are randomly assigned to 3 different treatments. Limitation is that it does not take into account the effect of various extraneous variables. And the fifth one, that is randomized block design. Differences in the results could be due to differences in the sizes of the solves. Different unit sizes would have different extraneous factors. And in case of Latin square design, it allows the researchers to control and measure the effect of 2 extraneous variables on the dependent variable. Treatments are designed and assigned randomly to the cells of the table in such a way that each treatment appears once and only once in each row and in each column. Then the variance technique could be used to separate out and measure the effect of 2 extraneous variables. That's all about the fourth unit. So it was about the research design formulation. Thank you all for being with us.